working as assistant professor in the Department of ECE at Institute of Aeronautical Engineering College. So today I'm going to give a basics of probability theory. What is probability? So what are the functions in probability and various calculations like mean, variance for random experiments. So probability definition, we have a terms, an experiment, sample space, and event. So what is an experiment? So repeated actions to know the outcomes. So that is known as an experiment. So in the experiment, suppose when you coin experiment, we have an outcomes, head and tail. So this is sample space. Total possible outcomes is called sample space. So this is the possible outcomes for a coin experiment, and each subset is known as event. So what is an event? Head is an event, tail is an event, and nothing occurs, no outcome. That means final. Null is also an event. So for any experiment, there is n 2 power n number of events. So n is the number of possible outcomes. So here 2 outcomes are there for a coin experiment. So totally we are having 2 power 4 times. So in the definition of probability, so we are having a relative frequency definition. The relative frequency definition is, suppose an experiment is repeated by n times. The same experiment is repeated by n times. So how many times an event A occurs? How many times the event occurs among total events? So that is known as the probability of event A. So this can be written in mathematical form like limit n tends to infinite f by n. Here f is the number of times the event A occurs and total number of times the event is repeated. Suppose I repeated an experiment 100 times, coin is tossed. In this 100 times, 60 times head appears. Then what is the probability of A? A is head. How many heads occurs in 100 times coin tossing? So here 60 times it is occurred and out of 100. So this is the probability of an event A. So this will get exact accuracy when the experiment is repeated by n tends to infinite. That means we have to repeat the experiment by infinite number of ways. We are going to get the probability of A. And this probability of A lies between 0 and 1. 0 and 1. We know the uncertain event, it is 0. It is impossible event, it is 0, which will not happen never. So its probability is 0. And the compulsory happen event, it is 1. It is 1. So there are some axioms for probability. Axiom 0, probability of A is 0 for impossible event and probability of A is 1 for certain event. Certain event. So always lies between 0 and 1. And the third axiom is, suppose I want to find the probability of A. It is having so many events. A contains so many events. Is found by adding the probabilities of all events contained in the A. So total probability is events contained in the A. So we have to sum all the probabilities. Based on the 3 axioms, the probability theory is developed. So basic formula for probability is possible outcomes by total outcomes. Possible outcomes by total outcomes. Total outcomes. Next one, we are having conditional probability and joint probability. Suppose in set theory, you know set A and set B. Set A and set B. This diagram, you know Venn diagram. So the region, this is known as joint probability between A and B. It can be denoted as A intersection B. So it is called as joint probability. So it is called as joint probability between events A and B. Now what is conditional probability? Conditional probability is, Suppose an event A depends on an event B. That means event B has occurred after only event A will happen. What is the meaning of A given B? Here condition is there. Conditional probability. A given B means event A will happen after B only happens. So event A depends on event B. So this can be defined as it is joint probability, probability of A intersection B divided by probability of B. Suppose you are writing how much dependency of B on event A, that is equivalent to joint probability of A intersection B divided by probability of A. So this is conditional probability. So next, events are independent. That means A is an event and B is an event. Independent. When dependency is there, we should write this conditional probability. If dependency is not there, we should write independent events. Then what is probability of A given B? A does not depend on B. So this is equivalent to probability of A. B given A. B does not depend on A. So probability of B. When independent, conditional probabilities are equal to normal probabilities. And one more condition is there to check dependent and independent. So when A and B are independent, its joint probability is product of two independent probabilities. So A intersection B, this is joint probability, product of individual probabilities. If this condition satisfies, then also A and B are said to be independent. So all these probabilities can be used in information theory. So suppose this is source 1 and source 2 are we want to dependency between the information. Suppose as I am speaking, my statements contains like first line and second line. If the second line depends on first line, so we should know the dependency in terms of conditional probability. How much the second statement depends on first statement. So that is converted into probability. Based on the probability, if it is required, which probability is higher, that should be transmitted. So like this, all these statements are useful in the information theory. Next, what is a random variable? So just now we discussed the previous slide's probability, but random variable is derived from the probability. What is random variable? Random variable is a real valued function that maps all elements in the sample space to the real values. So as I know, coin experiment, head and tail are the outcomes. These are English letters. But when we are doing mathematical model, we need to assign some values to head and some values to tail. That is the concept of random variable. It assigns real values to the sample space. So head can be assigned as a real value 0, tail can be assigned as a real value 1. So assigning of the real values to the sample space is known as the random variable. It is a real valued function. It is a real valued function. Then example, see here. So a coin is tossed 2 times. This is the sample space. These are the possible outcomes. In first outcome HH, first trial H, second trial T, TH, TT. So these are the possible outcomes. After that, X random variable X is defined like this. How X is defined? X is defined like this. X denotes the number of heads in the coin experiment. So you have 2 heads are there in the first experiment, in the first sample, first event. Second event, we have only one head is there, and third one head, and fourth event, we are having no heads are there. So X can take the values from 0, 1 and 2. 0 represents 0 heads. So possibilities are T comma T, 1 head. So possibilities are head comma tail comma 1 head. This is the random variable 1 values possibilities, and random variable 2, the possibilities are H comma H. So this is 2 heads. So this is about the random variable introduction. So after random variable, these are classified into 2 types, continuous random variable and discrete random variable. So let us see what is continuous random variable and discrete random variable. So discrete random variable is it assumes only finite value. So the name itself, discrete, means it assumes only finite values and countable. It is countable. Random variable, discrete means it is finite value, its value is finite and countable. Earlier said example, x takes values 0, 1, 2. So this is a discrete case which is finite and countable. Example, suppose number of accident per month, number of telephone calls per unit time, number of success in trials. Suppose these are example for discrete random variable. Then what is continuous random variable? So continuous and infinite values. Suppose the random variable contains infinite value. For example, I have an experiment like wheel is there. So on the wheel, the number 0, 3, 6, 9, 12. So like this, numbers are there. So it is rotating. It is rotating and it can choose any value between 0 to 12. Now sample space is 0 less than or equal to less than or equal to 12. So here the sample space is continuous. X can, any value means it can take 0, it can take 1.293 or 3.912, it can take any value. So it contains infinite possible values. It contains infinite possible values. So that type of random variables are called continuous random variable. So real numbers from 1 to 6, speed of a car, weight, pressure. So all these are examples of continuous random variable. So after knowing the definition of random variable, we have some functions: probability mass function, probability density function, distribution function. There are certain functions are there to represent probability values. So that is probability function. This probability function maps all the possibilities of values of x against their probability of occurrence. So we know head experiment, coin experiment, head tail. Suppose random variable values as head for 0 and tail for 1. So this experiment, the real values and their probability are represented by using a function that is called probability function. So always the area under probability function is 1 because we know the probability values always lies between 0 and 1. So same, the area under any probability function for any experiment, the area varies from 0 to 1 only. Final value is 1. Now we discuss about probability mass function. What is probability mass function? So we have discrete random variable and we have continuous random variable. So as I said, this is finite and this is infinite samples. When we have finite samples, we have a mathematical operation sigma. Sigma x equal to 0 to 1. What it means? X equal to 0 plus x equal to 1. X equal to 0 plus x equal to 1. That is the meaning of sigma. So the sigma is used for mathematical calculation of discrete case. For continuous case, we have infinite values are there. We should do integration mathematical operation for the calculation of the various parameters of the continuous random variables. So here integration, lower limit and upper limit. So discrete random variables. So example, what is probability mass function? What is probability mass function? In discrete case, the probability function is called probability mass function. Here I am having an example and how to draw this probability mass function for this example. So probability mass function is for discrete random variables only. We can say it's discrete random variables, this probability function called as probability mass function. What is this probability mass function? It is, suppose outcomes are x equal to xi. Suppose outcomes are x equal to xi. So at xi, what is the probability? At xi, what is the probability? We have to know. Probability at x equal to xi. So suppose in die experiment, so you have a cube die experiment. It consists of 1 to 6 numbers die. So what are the outcomes of a die? It is 1, 2, 3, 4, 5, 6. So these are the outcomes. So all are equally likely. That means any outcome can appear. So what is the probability? Total outcomes are 1. And what is the possibility of getting 1? 1 by 6. All are equally likely. So the probability for die experiment is 1 by 6. Suppose what are the values for random variable? Now random variable x is 1, 2, 3, 4, 5, 6. What is 1? Getting number 1 on the die. 2 on the die. 3 on the die. What are the probabilities? 1 by 6. 1 by 6. 1 by 6. 1. All are equally likely. Suppose we plot x-axis as random variable values and y-axis their probabilities. That is called probability mass function. So random variable values are 1, 2, 3, 4, 5, 6 and the probabilities are equally likely 1 by 6, 1 by 6, 1 by 6. So this is called probability mass function. If you observe, it is discrete because random variable values exist for 1 and 2. In between 1 and 2, we don't have information. So this is discrete. Next, we'll see distribution function for this die experiment only. What is distribution function? So distribution function, the definition is, suppose we are having x values lies for 1 to 6 for die experiment. 1, 2, 3, 4, 5, 6. Suppose capital X is the random variable value. We can take the value of the random variable x. The small x is the value of the random variable. The value of the random variable you can consider up to 1, up to 2, up to 3, up to 4, up to 6 also. So distribution function means it is a cumulative process. So cumulative means additive process. Suppose it is defined as, it is represented with f of x. It is defined as probability of x less than or equal to x. X less than or equal to x means what is the distribution function for x equal to 1? What is the distribution function for x equal to 2? Like this you have to calculate the distribution for x equal to 6. What is x equal to 1? It is x less than or equal to 1. What it means? We have to sum all the probabilities up to the value of 1. Up to the value of 1, we are having only 1 by 6. That is 1 by 6. When we are calculating fx of 2, it is probability of x less than or equal to 2. So what is the meaning of probability of x less than or equal to 2? So we are having two values x less than 2, that is probability of x equal to 1 and probability of x equal to 2. Two values. So this is 1 by 6 and this is also 1 by 6. So we are going to get the probability of x less than or equal to 2, 2 by 6. Like this, x less than or equal to 3, 3 by 6. X less than or equal to 4 by 6. X less than or equal to 5, 5 by 6. X less than or equal to 6, 6 by 6. So total last final value of distribution function is 1. So this is distribution function. If we plot the random variable values on x-axis, that is 1, 2, 3, 4, 5, 6. Die example only. A random variable value 1 to 6. And the probabilities for x less than or equal to 1, 1 by 6. X less than or equal to 2, 2 by 6. You have to take previous probabilities also you need to sum. That's why it is also called this distribution function as cumulative distribution function. So what is the meaning of cumulative? Summing. So we have to add the probabilities up to the value of x. Up to the value of x, we need to sum all the probabilities. So probability of final value, x less than or equal to 6, its final value is 1. So this is about discrete random variable, mass function and distribution function. Now let us see continuous random variable. In continuous random variable, density function, it is named as probability density function, PDF. For a discrete case, it is called as probability mass function. Probability mass function, but continuous case, we can call it as a density function. Now see the example here. We have a negative exponential function. Negative exponential function. Negative exponential means it is mathematically it can be written as e power minus x. So here x can take any value from 0 to infinite because we know e power minus x only one-sided. One-sided means it can occupy from 0 to infinite, not from 0 to minus infinite. So x can take any value from 0 to infinite. So these values are infinite. So it is called as continuous random variable. So for continuous random variable, if you plot e power minus x with respect to x, that is called probability density function. So what is the area under this probability function? Suppose if we find the area, how to find the area of any curve? Minus infinite to infinite, area under that curve is equal to 1. So if we find the area under this density function, it has to get the area as 1. Next, suppose I want to find the probability between 1 and 2. Probability between 1 and 2. What I need to find from the probability density function, we need to find the area in the curve. 1 to 2, how much area it occupies, it gives the probability of that curve. So these functions mainly used in the calculation, in the modeling of random variable, and finally for any locations or for any limits if we want to find the probability, these functions are very useful. So this is e power minus x. Then what is its distribution function? What is this distribution function? Its distribution function, it is capital Fx of x is integration of density function. So we need to do integration for obtaining distribution function. So this is distribution function. So we have to do the integration of density function. So as you know the limits 0 to a, we need to do the integration. So distribution function is e power minus x integration, we know e power minus x by minus 1. So limits 0 to a. Suppose if we substitute here 0 to infinite e power minus x dx. In place of infinite, here a is there in the calculation of CDF. But if we replace infinite, what happens? So e power minus x by minus 1, limits from 0 to infinite. So you know e power minus infinite is 0 minus e power minus 0. So you'll get the area as 1. So this is the formula to find the area, and this is to find the CDF. In the calculation of CDF, we need to integrate up to x only. Okay, up to x, fx of x dx. So take the up to the value of x, we need to integrate in the calculation of distribution function. So this is the distribution function of e power minus x, that is 1 minus e power minus a. Then we have very important parameters here, mean and variance for a random variable. So what is mean of a random variable? So generally mean is nothing but average value. So how to calculate this average value? By using probabilities. Suppose we are having a data 1, 2, 3, 4, 5, 6. Then we can do the average value, sum divided by total. But here we have probabilities and a random variable. So we use the operation expectation in the calculation of the mean. So what is the expected value of x? We know random variables are two types, discrete and continuous. For discrete case, we will use this summation, and for continuous case, we will use integration. So how you are doing naturally average value? You need to add x value, 1 plus 2. So you have to take all the values of xi. And denominator we are having 6. What is this 1 by 6? We can write it as like this also. So summation we can write it as like this also. 1 plus 2 plus 3 to 6. So this is called probability of the occurrence of event A. So that's why it is equivalent to Pi and Xi. So what is the expected value of X? It is summation of Pi into Xi. What is Pi? The probability of occurrence of random variable and the random variable value. This is called the mean value of the random variable. Then for continuous case, this integration is replaced with summation is replaced with integration and random variable, and probability is replaced with the density function. So this is the mean calculation for the random variable. One more parameter is there for a random variable, that is variance. So what is mean? Gives the average value, Mean we use the average value, and variance gives spread of the distribution about its mean value. Spread of distribution about its mean value. Spread means, suppose I have a Gaussian function like this. This is a Gaussian random variable. So it is symmetrical about mean. Its maximum value occurs at mean and it is symmetrical about mean. So this variance gives spread of the distribution about its mean value. So too many curves are there like Gaussian like this. If spread is more from the mean, then your variance is higher value. So the significance of variance is it gives spread about the mean value. Okay, it can be calculated by using the formula E of x square minus E of x whole square. This E is nothing but expectation operation, as in the previous slide. It is for continuous case, expectation formula is x into probability of x. For discrete case, minus infinite to infinite, x into fx of x dx. So these are the two formulas. These are the formula for finding the expectation. So this is called mean square value and this is called mean value. So variance of x is mean square value minus square of the mean. After calculation of variance, you can calculate the standard deviation also. It is square root of the variance. All these plays a vital role in the communication system design and in compression also. Next we have, as I told earlier, this Gaussian density function. It's mathematical equation, and this Gaussian density function is maximum at the mean. Here Ax is called mean and sigma x is called variance. Suppose the curves separated by different width. So this width is different and this width is different. So sigma value for this one is smaller and sigma value plus this one is larger. The sigma indicates spread from the mean. So width of the curve is decided by sigma x. X minus ax. X minus ax means ax is called the mean value of Gaussian random variable. So we have different random variables in real time. So these random variables can be used in the analysis of experiments. Suppose a water drop falls from the sky to earth. So we want to analyze the water drop size. So how much size is taking in the sky as the distance traveled to the earth, how it is falling. So is there any distribution which is following based on that one? We can assume any one distribution, a pre-known distribution. So we can use those distributions in the analysis of these types of problems. Next we have uniform density function also. What is this uniform random variable? Uniform random variable, some area, some points, between some points, it will have equally likely, like die. 1 to 6, it will maintain equally likely probability. So probability is 1 by b minus a between the limits a by a to b. It is called as uniform random variable. It is also continuous, earlier also continuous. These two are continuous random variables. And if we go for discrete random variables, example, as we know, binomial random variable. So an experiment is having two possibilities, success and failure. When two possibilities are there, that means discrete, outcomes are discrete, then we will use binomial random variable in the calculation of probability. Okay, success and failure. What is the probability of success and what is the probability of failure? So this can be written as NCR, P power R, Q power N minus R. So N is the number of times the experiment is repeated, R times success comes. So what is the probability of success and what is the probability of failure? So if only two outcomes are there, suppose success or failure, if we want to calculate the probability of the type of experiments, we can use binomial random variable. Whenever from certain region A to B, the probability is uniform, it is 1 by b minus a, then we can use uniform density function. So always the area under this curve and the area under this curve always unity. That is what probability. The area under any density function is always unity. So this is about very small introduction about probability theory. All these concepts are used in the analysis of communication system. Like suppose I have a data is there. I have a data is there like this all ones. Suppose I want to reduce the size of this data. What I need to do, I need to find the covariance or correlation between 1 and 1. There we are using the concepts. All probability concepts are used in the reduction of data size, which is important and which is not important. The probability of data transmission is going to measure in the information theory. So we are going to use these probability concepts in the information theory. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.